Welcome to Softlearning, where we build practical Python tools step by step. Today we were creating an audio noise reduction tool in the browser. You will upload any WAV or MP3 file, strip out background haze, and download a pristine version, all with under 50 lines of code. Let's get started. First, install our dependencies in one go. Type pip install Streamlit, Librosa, Soundfile, Noisereduce, NumPy, and hit enter. This pulls in Streamlit for UI, Librosa, and a Soundfile for audio I/O, Noisereduce for the cleanup algorithm, and NumPy for array work. Once that's done, open your editor to a fresh app.py file. We start with import Streamlit as ST. This alias ST is our gateway to building UI elements, buttons, sliders, audio players, and more. Next, import Librosa. Librosa is a gold standard for audio analysis. It will load our files into NumPy arrays. Then import Soundfile as SF. While Librosa can save, Soundfile gives us precious control our WAV encoding back into memory. Import Noisereduce as NR brings in the core noise reduction engine. No black box APIs, pure Python DSP under the hood. Import NumPy as NP is obvious. Audio is just numbers, and NumPy is perfectly optimized for that. Finally, import I/O. Let us create file-like streams in memory so we never write temp files to disk. Everything stays in the wrap. Now that our imports are set, we call st.title function with our app name. Streamlit will render this as a prominent header, immediately conveying to users this is an audio noise reduction tool. A clear title is critical for the first impression and helps orient anyone who lands on your page. Next, we add st.file_uploader function. The first argument is a label. Make it instructional so user know exactly what to do. Here, we specify type WAV or MP3, which restricts the file dialog. This avoids unsupported formats and prevents runtime error. Uploaded will be a bytes IO like object. Once a file is chosen. Before that happens, it's none. So we will guard our processing logic behind if loaded. Using built-in Streamlit pipgates cuts out all the HTML and JavaScript boilerplates. Focus on Python, not frontend. We start with if uploaded. These checks ensures our code only runs after the user actually selects the file. Inside we call Librosa.load function. SR equal to none preserves the file's native sample rate. Crucial if you care about fidelity. Mono equal to true collapses stereo into a single channel, simplifying downstream processing. This function returns the Y. In NumPy, array of audio samples normalized to floats between -1.0 and +1.0, and SR, the sample rate in Hertz. This step transforms a file on disk into raw data we can manipulate with Python. Now for the code, nr.reduce_noise function. Under the hood, Noisereduce analyzes crate segments to estimate a noise profile, then attenuates those frequency bands across the entire clip. You can supply extra parameters like prop_degrees to control strength or even pass separately y_noise sample. But defaults are intelligently chosen. The returned reduced array is the same length as y, but with significantly less background haze. No extra binaries are cloud called. This is pure Python DSP in action. To let users listen, we convert our arrays back into wave bytes in memory. Buff_orit variable equal to io.bytes io function creates an in RAM buffer. No temp files for cluttering your project folder. sf.write function encodes the original audio into that buffer. We repeat for buff_clean, writing the cleaned samples. Now we have two files like objects, each containing valid WAV data, ready to stream directly to the browser. First, st.subheader functions add a clear label for our players. Important thing is call buff_origin.seek function to rewind to the start. Otherwise, the buffer's cursor is at the end. Then st.audio function renders an HTML5 audio player. Viewers click play to hear exactly what they uploaded. background hiss, and all. This immediate feedback is great for demos and helps viewers trust your tool. Next, label the cleaned section with st.subheader function. Rewind buff underscore clean with C function. You will get silence if you skip this. st.audio function then displays another player. This time playing the T hissed output. Viewers can instantly A by B test, click back and forth to compare raw versus proceed audio. This side-by-side demo is highly compelling and boosts watch time. Finally, rewind buff underscore clean one last time. We call st.download underscore button function with a label, our buffer, a file name, and the correct meme type. This generates a clickable button when users press it. The browser downloads cleaned.wave straight to their machine. All done in pure Python, no server-side storage required. Now let's run our Streamlit app. Open your terminal and type Streamlit run app.py. Streamlit will automatically open a browser windows for your interface. Once the app loads, we will upload our audio file. Here I have got an MP3 called Noise. Just drag it in or use the uploader widget. The app shows two players, one for the original audio. Let's click play to hear the unproceed file. Notice the background hiss and hum. Now scroll down to the cleaned audio section and press play again. Hear the difference. The background noise is dramatically reduced, yet the speech remains clear. Happy with the result? Just hit download cleaned audio and get your final wave file instantly. No extra tools, no manual filtering, just clean the output right in your browser. And that's a full walkthrough of our noise reduction app powered by Python and Streamlit. Don't forget to subscribe to Suflearning for more hands-on projects just like this. Drop a comment below if you want an advanced version, maybe with waveform visualization or patch cleaning.